Hello student, this is the part 3 where we are going to cover the circular linked list. My name is Drashti Mori and I am from the New LJ Institute of Engineering and Technology. As I said, we are going to cover the circular linked list and their one operation, that is deletion operation. As all are aware about the normal linked list, that is known as a singly linked list, right? In singly linked list, last node have the address null. Last node would point to nothing, so it point to the null. But in circular linked list, last node have the address of your first node. It is very important why we are having some type of mechanism where we have to do continue iteration of each and every node. As based on the application, we decide which data structure we will select for our problem solution. As here one example is given, that is round robin time sharing mechanism. Whenever we want to do multiple tasks, system use the round robin method. This is one logical representation of your circular linked list where last pointer will point to the first node. Now it is a way round robin work. Whenever one process had completed their given amount of time, it will join the list at the last, or then again whenever their turn come, it will process. So this way circular linked list can be used. Then after we will see the one operation, that is deletion. Here old is a location, memory location, which node need to be deleted, right? Here 106 is the location which need to be deleted from your circular linked list. How can you know it is a circular linked list? By looking at the last node. Here last node is M. 105 is the location where our last node is M. So M is locating to what? 103. 103 is my first node. So it is a nothing but your circular linked list. In circular linked list, we are maintaining two pointer. First pointer pointing to the first node and one more pointer which is last. Last point to the whichever the node which is last, it is given by our last pointer. Fine. Whenever we want to do some deletion, we require two pointer which point to the temporary node and one is predecessor node. Why we require this? You all are aware. Because we want to get the address of your previous node. Then only we can update their link part. Fine or not? So what is the first condition? Check. My linked list is empty or not. If it is empty, no need to traverse or check and all. So first condition is check. My linked list is empty or not. Then after initialize your save pointer. Save pointer initialize with your first value. First is right now having 103. So save is 103, right? Then after what will happen? We have to iterate throughout our linked list. So we want to stop only when we reach to the old location. Old is located to 106. So we want to traverse in our linked list till we reach our 106. Or it can be possible that we reach to the last node. If so, these two conditions need to be checked. And if it is not a case, we want to traverse. And for traverser, you know, 103 would be updated in predecessor pointer, yes, and save pointer would be updated with the link save. What is link save right now? 106. Yes or no? 103 have link part 106. So it can be modified. Then after we reach the last location, that is 106. 106 is the same as old. So condition is false. We come out of loop and we reach the stage where you have to check that given address is same as old or not. If it is not matched, in that case, your deleted node is not present. Yes. So you should write the error message and then come out of your program. Yes. And the fifth step is if our case first is equal to last, in which case first and last are pointing to the same node. In the case where you have only one node, yes or no? In that case, if we reach the right location but it is the only node in your linked list, in that case you have to modify your first and last pointer. So first and last pointer should point to nothing, means null. Fine. And it is not a case. And if we need to only delete our first node, but linked list is very long, but only you are wanting to delete your first node. In that case, you need to update your first pointer. And first pointer is updated with the first. Whatever the second node, it would be fetched in your first. Fine or not? And then after we need to update our last pointer link. Why so? Because last pointer is also pointing to the, in our case last have pointing to 105 and 105 is pointing to 103, but in the case that 103 need to be deleted, and that case 105, which is the m node should link to what? Not the 103, but it should link to the 106, because now our updated first is 106. So this modification need to be done in case of you want to delete your first node. Fine or not? Then after, if these all are not the case, then we are deleting the some middle part. In our case, as we want to delete, it is the middle part, D, J and M, and we want to delete our J. J is the middle node in your linked list. In that case, what you need to do, 103 link part should be updated with your 106 link part. What is 106 link part? 105. So 105 need to be updated in your predecessor. So predecessor is this. Predecessor link part is this. So now this is going to be updated. Fine or not? So this way you have completed our operation of deletion. Now node J need to be deleted. So what do you mean by deleted? We want to refresh that. When I say refresh means what? We want to free that node. Yes or no? So this last point would be free our node. Fine or not? And what was the sixth step? Sixth step is, if we are at the last node, then which need to be updated? Last pointer need to be updated with your predecessor. So these all are the condition need to be addressed while you want to delete something from your circular linked list. I hope you are clear with the deletion part in your circular linked list. Thank you for this video lecture.